Hi, everyone. Thank you again for joining the Robin webinar series. My name is Matt Miller, and I'll be your host for today's webinar. Before we start, just a couple of housekeeping items before we jump into the presentation. First, all the attendees are in listen-only mode as to alleviate any background noise on today's session. So if you do have a question, please feel free to enter it in the question module on the GoToWebinar dashboard on your screen. We'll definitely leave some time at the end of the presentation to go through as many of your questions as we can. Lastly, today's session is being recorded, and you will be sent a link after the presentation, which you can share and view. So with those items out of the way, let's get into the topic for today. I'd like to introduce our speakers. We have Ankur Desai, who is the Director of Product Management here at Robin. Good morning, Ankur.
Morning.
And we also have Madhura Gaunikar, who is a Principal Engineer here at Robin. Good morning, Madhura.
Hello, good morning.
Great. Without further ado, Ankur, I will hand it off to you to start the presentation.
Thank you. Thank you, Matt. Hi, everyone. This is Ankur Desai from Robin. I'm the Director of Product here at Robin, and welcome to the webinar, Unlocking Multi-Cloud Portability for Stateful Applications on Kubernetes. Now, one might be wondering, why is multi-cloud portability so important, right? So if you look at the state of cloud survey, recent survey by Flexera, we see that more than 90% of enterprises have adopted a multi-cloud strategy. What that means is almost all of the enterprises in the world are using more than one cloud. Now, it is very obvious that when you have such a setup, sometimes you might have to move applications across these different clouds that you're operating, right? So that is why we're going to talk about multi-cloud portability today and why it is becoming increasingly important. I will also talk about some of the drivers that are forcing this strategy in enterprise, some of the challenges and the solution. Right? So why do we think enterprises are adopting a multi-cloud strategy at such a high rate, right? What are the key drivers behind it? The first one is to avoid vendor lock-in, right? They don't want to actually, rely 100% on a public cloud and be locked in to that public cloud services forever, right? They want the flexibility, even though they may not use it extensively. They want the flexibility of other solutions, other options to be used when needed. The second reason is the flexibility of applying best tools, right? So you might say that for Cloud A, I like their machine learning tools and their managed services for machine learning, but my data warehouse, I actually like my on-prem setup, right? So depending on what tool is the best for a given problem, people want to choose what infrastructure would suit for that problem solution. The third one is latency, right? Some workloads, some applications are extremely latency sensitive. So to enhance the performance, developers and DevOps teams need to locate the workloads actually very close to the end users. And here is where, sometimes, you see there are different cloud providers in different regions, and you have to adopt a multi-cloud strategy. Fourth one is compliance. So there are, regulatory reasons where one might have to actually comply with government regulations, right? So, for example, GDPR. We are not allowed to store European citizens' data outside of Europe. So now, if in a region, in fact, it is also sometimes country dependent. So in a given region, if you don't have your favored cloud provider, then you might have to adopt a different cloud. And once again, this enforces adoption of multiple clouds. And the last one is for resiliency and HATR, right? So what if AWS goes down. And this happened recently, right? If your entire setup was on AWS and no failover across clouds, your application would have gone down for an extended period of time. But if you set it up in such a way that in case of a disaster, you have a failover mechanism, then it gives you better uptime for your applications. So those are the critical reasons people are adopting multi-cloud strategy. And as we can see, these are compelling enough for almost all enterprises to adopt multi-cloud strategy. Now, when you have such a setup, right, it is very obvious that you may have to move workloads around these different clouds you're operating. And as a solution, Kubernetes has been evolving fast as the common platform. Now, there are multiple reasons for this, right? One is Kubernetes was meant for, modernizing applications in such a way that they are easily deployable and easily portable. So that is one, right? Kubernetes was built with application portability in mind. The second one is almost all clouds actually have very robust managed Kubernetes services, right? So it has truly become the platform that is available across all clouds. So once you actually build your application in such a way that it can run on Kubernetes, you have multiple deployment options, right? So as you can see, across the organizations that were using Kubernetes, and these are many, almost 87% organizations are using multiple clouds, right? In fact, almost 80% are using all three hyperscalers: AWS, Azure, and GCP. Now, in many cases, they would be using their managed services like EKS, AKS, and GKE. So a setup like this, right, where the Kubernetes deployment and management has already been taken care of, is very, very developer friendly. Now it becomes really easy to move your workloads around different clouds because there is a common service that can actually enable the deployment of the workload. Now you might think, okay, look, problem solved, right? There are multiple clouds for some reasons, right? The 5 reasons we discussed. And now we have a common platform that actually is available on all the clouds, and I can easily port my applications across all the clouds, right? But there is a caveat here. Kubernetes was built for stateless workloads in mind, right? To move stateless workloads around, it's pretty simple, right? You actually define a specification file, like a YAML file, and then Kubernetes takes care of the rest. You simply apply that YAML file on a Kubernetes cluster, and it will create exactly the same stateless applications, no matter where it is running. And that, in a sense, actually solved a big problem for the stateless applications. But even though Kubernetes was initially developed for stateless applications, according to the recent CNCF survey, 2020 survey of containerization, what we're seeing is stateful applications are on the rise on Kubernetes. Now it's a different ballgame, right? Because, and we'll talk about why it is, but almost 80% of Kubernetes users are either running stateful applications in production, or they're evaluating, or they have plans in the next 12 months to run stateful applications on Kubernetes. Now, I mean, this system, this platform was initially built for stateless applications, and it solved a lot of problems for stateful applications, including multi-cloud portability. But now you have a different breed of applications that are running on the same platform. And here, multi-cloud portability is not that simple, right? There are certain challenges with porting stateful applications across different flavors of Kubernetes on different clouds. The first challenge is moving the stateful application from one cloud to another is not simply taking a YAML file and applying to a Kubernetes cluster sitting in the other cloud. It actually entails shifting the application configuration, metadata, and data, right? All of the 3 things together in a consistent state to make sure that the application is correctly ported over. And data, needless to say, data is a critical component here, right? You can't leave behind your data. Otherwise, moving a stateful application without data doesn't make sense. The next challenge is there is no construct in Kubernetes to wrap all of these relevant components in a single entity, right? Now you may be able to, achieve multi-cloud portability by doing a lot of manual work and automation scripting, right? Where you, somehow individually capture the configuration, the metadata, and the data of a deployment, and then try to recreate it on the target cluster when you port the application. But there is no easy way out here, right? There is no application that you can simply take a snapshot of, which will take care of all of these moving components and give you the simplicity. And the third one is, data is stored in storage volumes in a given cloud, right? So that means that, for example, if it is running in AWS, it might be stored in EBS, and you now want to, move to Google. Now the underlying storage is persistent disks, right? So there are different storage dependencies and storage environments, and the data also needs to migrate seamlessly across these different storage providers, and make and we also need to make sure that the Kubernetes application running on top can easily access the data. So now with that in mind, right, how do we solve this problem? What is the first thing that is needed, especially given the third constraint or the third challenge, right? Because there are different storage environments across these different clouds, and including on-prem, right? On-prem, you might have something like a SAN or a NAS system running. How do you solve that problem where you need a common layer across all your Kubernetes environments? And that's where actually Robin Cloud Native Storage comes into picture, right? So this is the multi-cloud storage layer that can actually work with any flavor of Kubernetes. So if you look at the stack diagram, Robin Cloud Native Storage can work on any infrastructure. So this could be on-prem, or on bare metal or virtual machines, or it could be in public clouds, including AWS, Azure, GCP, IBM. And now on top of that infrastructure, you might have different flavors of Kubernetes, right? So on-prem, you would have upstream Kubernetes or OpenShift or Anthos, which are the most popular on-prem Kubernetes distributions. And in the cloud, you might use, the managed services provided by the respective clouds, like GKE, AKS, EKS. Now you need a common storage layer that can actually talk to all of these flavors and all of these combinations of Kubernetes and infrastructure. And that's where Robin Cloud Native Storage makes things simple for you, right? This is a common layer of storage and data management that can easily be deployed on top of a Kubernetes cluster, right? So this is not an external system that will connect to Kubernetes, but rather when you have a Kubernetes cluster up and running, you simply install Robin as a native Kubernetes operator, and it will create a storage pool on top of your Kubernetes cluster. And now Robin becomes the storage layer for all the stateful applications running on top of it, right? So it could be databases or your NoSQL databases, your messaging queues like Kafka, time series databases, big data, and AI/ML applications that need access to data. So here, when you deploy your stateful applications, let's say you're using the Helm chart to deploy a Postgres database, you simply say the storage class is going to be Robin, right? And from there onwards, now you have the benefits of a common multi-cloud storage layer managing your storage, as well as we'll talk about other benefits that will simplify how you can move applications across the cloud. At this point, I would also like to mention that this is a product that has been trusted by Fortune 500 companies for mission critical apps, right? At Palo Alto Networks, we have about 6 petabytes of big data applications running in a Cloudera cluster on Robin. At USAA, they are running more than 2.5 petabytes of data in the Elk stack for security analytics. And Sabre has more than 400 Oracle databases running on top of Robin. Also, this product has been recognized as one of the leading products in the industry for Kubernetes storage. GigaOM has recognized Robin as a leader and outperformer both for Kubernetes storage and for Kubernetes data protection. And Gartner has actually included us in multiple foundational research notes about Kubernetes. And IDC has called us an innovator in this space. So now, let's say the first problem is solved. We created a multi-cloud storage layer, right? It goes across different flavors of Kubernetes. Is that enough? The answer is no, not nearly, because there are other problems, right? We talked about having no application construct in Kubernetes for a stateful application. So what we need is a cloud native storage solution with an application perspective. And when I say application, right, it's this is what I mean in the context of a Kubernetes application. So an application is more than, or a stateful application is more than just the data, right? Just the storage volumes. When you deploy something like a database, there are multiple components in Kubernetes that are created as a part of the deployment. The first one is data, which will be held in persistent volume claims. But you also create configuration. So these are things like config maps, secrets, labels, right? So all of those things are very relevant to the actual deployment of the application and also at the actual topology of the application. And the third is the metadata you create, right? So your application is running pods or stateful sets, right? There is, what were the resources given to each pod, how many CPUs, how much memory, all of that information is captured in the metadata. So in order to actually move this application, you need to capture all of these components, right? It is also important to actually make sure data is consistent. Before you actually move the application, right, you have to make sure that you are capturing the correct state, and we'll talk about that. And then data management for applications, things like application portability, have to be easy enough for developers to actually carry out, right? In the past, for certain things, you would get storage admins involved, you would get IT operations involved. With the whole DevOps culture, we also want to make sure that not only the solution is complete, but it is easy to use for the end users like developers. And that's where Robin helps, right? So once again, Robin simplifies this by creating a single entity out of all of these moving components on Kubernetes, right? So when you register an application with Kubernetes or with Robin, it understands all of the components related to that application, and it will give you a simple, a wrapped entity that you can move around, or you can perform data management operations on. So as you can see on the screen, these are simple single commands that you would run to register an application with Robin. And now Robin will auto-discover the application's components, including data, metadata, and configuration, and it will give you a single entity that you can manage going forward. Right, so we have solved two problems so far. One is we have created a multi-cloud layer. The second one is we have created an application construct to wrap all of the components in a single entity, right? Are we good yet? Probably not, right? Because now, even if you have created a single entity, this is a constantly changing entity. You have a database, and if it is being used in production, or if there are connections to the database, they are always writing data, reading data, right? So you have to be able to port the application correctly. You have to first capture a application consistent snapshot, capture the correct state of the application, right? And that's another thing that Robin actually simplifies. So with a single command, Robin snapshot application one, and then give it a snapshot name, Robin will capture the data, metadata, and configuration, because we have created a single entity, right? And you are giving the name of that single entity to Robin and saying, capture everything related to this application. So if it's a database, we will make sure we will query the database. We will create a consistency group across all of the components that are related to that database, and then we will capture the snapshot. Now here it is worth mentioning that snapshots are important for multi-cloud portability, but at the same time, snapshots can also be used to recover from user errors, right? If you delete something, an important table in your database, you can easily roll back to a point in time where you had a stable state, right? So those are some other benefits of snapshots, but in this presentation, we'll talk mostly about the multi-cloud portability aspects. Okay, so we have solved 3 problems so far. We have created a common multi-cloud layer. We have created a single entity that is easier to manage. And now we have a mechanism where we can actually capture the correct state of that complex entity, right? The next step in this solution is to be able to capture the state of the application and that, create a backup and move it to the cloud where it is accessible to multiple Kubernetes clusters sitting on different clouds. So here, once again, it starts with snapshot, right? We will snapshot the application and capture, its correct state, including data, metadata, and configuration. The next step here is once that snapshot is captured, Robin makes it easy to push that snapshot as a full application backup on a backup target in the cloud. Now, this could be, an object store like S3 or GCS, right? So this is a cloud backup that can be accessed by any Kubernetes cluster that has access to this repository. So in Robin, we actually call it a repository, and you'll see it in today's demo that Madhura will be doing in a short while, how easy it is to capture a state of an application and then push it to cloud. And then, once we are there, right, once that state is captured and it is in the cloud and it is accessible to other Kubernetes clusters, we are getting somewhere, right? So far we have solved 4 problems. One is creating common layer of storage. The other one is creating a single entity. The third one is capturing the correct state of that entity. And the fourth one is actually pushing that state to a common repository in cloud where multiple Kubernetes clusters can access it. One other thing I would like to mention about the Robin backups is these are forever incremental. What that means is, if you create the backup for the first time, it will actually create the full copy of the data. But like I said, these are constantly changing applications. More data is being added, so you cannot actually create a full copy every time you need a backup, right? That will not be an efficient strategy. So what we do is basically once the backup is created, after that, when you run a backup command, we will actually make sure only the incremental data is captured, and it will be sent over the wire to the cloud backup. And also these backups, because these are sitting in the cloud and accessible to multiple teams and multiple Kubernetes clusters, we also want to make sure we are enforcing an RBAC, role-based access control mechanism on top of it. Only the authorized users will be allowed to use this backup to recreate the application. So far, since we have solved these 4 problems, the last steps becomes basically recreating the application on the target Kubernetes cluster. Now the setup here you see, right? It's not just different clouds. Here it is also different flavors of Kubernetes. So I'm going to take a backup of a database on my on-prem Kubernetes cluster, and I want to make sure that the application, right, the database can be recreated in the exact same state on AWS and on GCP. And not only that, in AWS, I'm not going to run upstream Kubernetes like I run on-prem. I'm running EKS, right? On GCP, I'm running GKE. So as long as you have the common Robin storage layer running across these Kubernetes clusters, it becomes really easy to port these stateful applications to different clouds and different Kubernetes clusters, right? So it is as simple. Once again, it starts with snapshot because you have to capture the correct state of the stateful application. And then you actually push the snapshot to a common cloud object store, which we call a backup repository, right? So here you can store all of your backups. And all the authorized users now can access this repository and pick a backup and say, I want to restore this backup in its entirety on a target Kubernetes cluster. So here, on the EKS cluster, you would simply say, Robin pull or Robin import backup from this bucket. And Robin will take care of the rest, right? He will get the entire application in its exact state running on EKS, even though the source cluster was running a different flavor of Kubernetes, right? So to summarize, we have solved 5 problems. We have simplified multi-cloud portability for stateful applications using Kubernetes, and we have solved 5 problems. First, we have created a common multi-cloud storage layer. Second, we have created a single entity to manage out of stateful application on Kubernetes. The third one is we have created application consistent snapshots to capture the correct state of this single entity. Fourth, we have created cloud backup buckets, right, where you can push the single entity and store it as a backup so that multiple clouds can actually access it. And the fifth one is we have taken care of different flavors of Kubernetes. We have created a common ground between them, and we have made sure that with a single command you can restore or you can recreate these applications across different clouds, right? So with these 5 steps, now you have a simple solution, right? You actually have something that you can easily use, a developer can easily use without having to create IT tickets. These are all single commands where you register an application, create a snapshot, create a backup, and then import that backup. And we'll see that in today's demo that Madhura will be doing shortly, how easy it is to deploy a database on Kubernetes in GKE, and then use this mechanism to actually quickly recreate the same database with all its data and configuration and metadata in AKS, right? So with that, before I hand it over to Madhura, I would like to point a few things out. One is Robin Cloud Native Storage is, we have a free for life Express edition that is available at get.robin.io. So if you are interested in trying out, how Robin can simplify multi-cloud portability for you, you can go to get.robin.io, simply register and download the free for life edition. It is, valid up to 5 nodes. So, you can try playing around with it. And if you need more information, or if you would like to get in touch with an expert at Robin, you can reach out to us at slack.robin.io. This is our Slack channel, which is open for everyone. And you can find the relevant documentation at docs.robin.io if you want to, once again, try this out yourself. With that, I will hand it over to Madhura for the demo. Let me stop sharing my screen.
And while we're waiting for that transition here, just a reminder, we do have a couple of questions that have come in on the question board, which is great. We will take the time to answer those once we get back. But if you do have any additional questions, please submit that into the question module.
Matt, can you make me the presenter?
I can make it the presenter.
Hello, thank you, Ankur. So in today's demo, we'll see how we can use Robin for multi-cloud app portability. And for that, what are the workflows? So at first, what I'll do is we'll deploy a Postgres Helm chart. Then we'll take a snapshot of that Postgres DB and back up that DB to the cloud. And once that's done, we'll port that entire application onto altogether a different cloud platform. So without much further ado, let's begin the demo. So what you see here is my GKE cloud. So I'll see kubectl get nodes, and you can see here that I have 3 node GKE cluster. I'll also show you the storage class that we have here. So GKE comes with the standard storage class that is called as standard, and it creates the GCPD provisioner. I have already installed Robin on this, and that's why we can see here we have Robin storage class available. So in today's demo, I'll create a Helm chart or a PostgreSQL, and then I'll use this, and while creating a chart, I will use this Robin storage, and then we'll see how we can use this Robin storage for various other data management capabilities. So to start with, let me create an app using Helm chart. So what this will do is this will install a PostgreSQL Helm chart from the stable repository. And very important point to note here is that I have specified Robin storage class for creation of an app. If you don't do this, then Robin will not be able to recognize the app and will not be added to the Robin. So this is a very critical step. If you want to avail the Robin's data management capabilities, please be sure to set the Robin storage class. So let's see what has happened here, right? Let's see whether our PDCs are created. Yes. So as we have specified Robin storage class, our app is created with Robin storage class. Sorry, PVC is created with Robin storage class. So I was mentioning about different storage classes available, right? What all can we do with Robin storage class? So let me just show you an example of another advanced storage class of Robin that supports. So we provide various different parameters that you can avail. For example, what can you do? Replication. You can set the replication factor to 2 or 3, or by default, it is set to 1. So when you do this, your data will be replicated across 2 or 3 nodes disks based on the what fault domain you specify. So we also support RAG. So if you have your cluster in which you have your cluster across multiple zones, like for US West 1A, West 1B, West 1C, and you say you want 3-way data replicated and across the rack, Robin will take care to place your data in such a way that it is across the different racks like A, B, and C. Further to that, we also support encryption. For today, we support Chacha 20, ES256, and 128. You can also avail compression. We support LP4. We can specify different block sizes, compression, file system types, and all these parameters can be set in storage class. As well, you can avail the storage class as annotations while deploying your Helm chart. We had already deployed a Helm chart, so let's see what has happened to it, right? So our Helm chart is up and running. Okay, so we had created a Helm chart with name Movies, and Robin has already discovered that Helm chart. So what happens when Robin discovers the Helm chart? When I say Robin discovers the Helm chart, it actually captures all the status objects that are necessary for that app to work. Like for example, it will capture PVCs, config maps, secrets, labels, pods, stateful stats, services, etc. Let's also see the pod that is running. Okay. So we see here Robin with Robin storage, we have deployed an app and it is running. Let's insert some data into that cluster. So for inserting data into the cluster, what we have to do is get inside the Robin pod first. Let me capture the name of the app. What next? We have to connect to the pSQL prompt. And I'd already specified some parameters which help me to grab the password faster. Further to that, let's create a database called as testdb. Let's connect to that database Now let's create a table. I'm creating here a simple table. The name of the table would be like to movies, and I'm going to add some few records in that table. So what I've done here is I've captured just a few 9 sample records from IMDb database, and I have added those records. So these are basically just 2018 some movies, random movies that I've captured. So let's see. Okay, now we have 9 records, some Fahrenheit 451, Next Ever After, and some records. So at this point, we have a database with 9 records added into it. What do we do next? So what I'll do next is I will create a snapshot of this application. So let's go ahead and create a snapshot of the application. Let me just clear the screen and let me show you the app name. So the name of our app is Movie, and we'll create a snapshot of this application. It's a very simple command, Robin snapshot create, name of the app. I'm just giving some sample description to it, which contains 9 movies. So what is happening right now? What is a snapshot? Snapshot is just a point in time checkpoint of your application. Here what happens is we capture, when we say snapshotting in application, we just do not capture the data that is stored in PVC. But Robin makes sure that we have captured the entire configuration of your application. So at this point, you had just one pod running, and so it will capture the what all annotations, what everything KTS parameters that were set for your pod, as well as it will take care of your data. So let's see what is the snapshot ID. So here it is. This is the snapshot ID of your name of your app Movie. So at this point, what all can we do with this snapshot? There are various things you can do with this snapshot. You can create a clone. You can. So what is a clone? Clone is basically a replica of your entire application. Also, if suppose to the data that was already present in your application, suppose by mistake you just happen to delete some records or delete the entire database table itself. So using this snapshot, you can go point in time at the time wherein you had taken the snapshot. For example, your currently has 9 records, and by some error, you just happen to delete your entire database. You can use this snapshot and go back to the time where you had 9 records. Another interesting thing that we are going to demo today are backups. You can use this snapshot to create a backup. Now, to create a backup, first what you need is a repository. As Ankur mentioned previously, repositories are nothing but just your buckets that are globally accessible across all the clouds. This is my GKE cluster, and I have used S3 bucket and registered it in Robin. So my name of my bucket is PGSQL backup, and I have given read-write permission. So what all you need for this S3 bucket is the name of the bucket, the path to the bucket, and just your credentials that can be used to access that bucket. By credentials, like this is AWS, so we need is access key and secret key. Just you have to provide this in the form of a JSON file and add it to Robin. Very simple. However, I've used S3, but you could have used GCS bucket, Azure Blob Storage, and it works across just fine. Now let's create a backup. So before we create a backup, what we have to do is we have to attach this app called as app movies to the repository that we have added. Let's do that. So when we take backup, we know that our backups will be stored, like metadata, whatever information is stored in that backup. So let's go ahead and create a backup. So Robin, a backup create, name which app backup you want to create. the name of the PG-SQL backup, and let's provide the snapshot ID. So it's already creating a backup of our movie, name movie, from a snapshot that we have given here. So when we create these backups, again, remember we are taking backup of entire application, not just the PVCs or the data that is stored in PVCs, but the entire application. For example, if your PostgreSQL was an HA PostgreSQL and you had 3 instances of your app, then it would have captured all the 3 PVCs, all the 3 ports, and all the configurations that are associated with it. So our backup is created. Now let's see what is our backup ID. Here. So our backup is up. So now what we are going to do? We are going to use this backup ID to recreate an app, same app on altogether a different cluster. So for the purpose of this demo, what I have done is I have created another cluster. And this cluster is on AKS. AKS is Azure Kubernetes Service. So you see, this is my AKS cluster. To make sure, let's see what are the storage classes associated with it. So Azure comes up with its 4 default storage classes, and we have already already installed Robin. So we have our Robin storage class available here. So again, for backup to work on the target cluster, we have to add the same repository that we had added on our parent cluster. So let me log into the cluster first. Now let's see repo. Okay. So here we see a same repository that added on the parent cluster is available on the target cluster, PG-SQL backups, the path to the demo, and the S3 bucket with the read-write permission. Now let's get the token from our parent cluster, which will export and will import on our parent on our target cluster, and we will be able to create a new app. I'll say Robin backup export and provide the backup ID. So now why tokens, right? Tokens are necessary so that your data is secure. If in case you don't have tokens too, we can directly use this repository and pull all the clusters, all the backups, and then you have to figure out which backup to be used. So instead of that, what we do is we give tokens. So you can use this token and import it onto target cluster. So what I'll do is I'll import this. Okay. So what happens when I say import, right? So now let's see Robin backup list, and the state is imported. So from the S3 bucket and using this token, Robin was able to pull the information that is needed, like segments and metadata information corresponding to that movies backup app that we had created and push to S3 bucket. Now, what is the use of this bucket ID? From this backup ID, we are going to create a new app. Mind you, we had created parent app on GKE cluster, and now we are going to recreate that app on target cluster, which is our AKS cluster, just using the backup ID. So let's create it. So I'll call the name of my backup cluster's app's name to be movies backup. I'll use this backup ID. So Robin app create from backup, name of the app, backup ID, and that's all you need. So what will happen now, right? While this is happening, what is actually happening is Robin will recreate all the PVCs, will spin up the pods, pull the data, and then have your all app ready for a function. So let's just see it in a pictorial version. So we had here GKE cluster. We created a snapshot. Then we have our S3 bucket. This we have used S3 bucket, but it could have been very well GCS, Azure Blob Storage, or Minio. We pushed the snapshot to that S3 bucket, and now we are pulling that snapshot on the target cluster, and then we will spin up the same app that we had created on GKE cluster onto our AKS cluster. So let's see what's happening right now. So this will create PVCs. Okay, so it has created a PVC that was available using the Robin storage. Name of the PVC is data movies backup. Now it will pull all the data, and then we'll have an app up and ready for our use. Okay, our job is completed. Let's see whether it has created pods. Yes, you can see we have a pod up and running. Let's do Robin app list, and you'll see we have added an app. So now let me just clear the screen for a clear visibility. And now let's go ahead and get inside the pod. Okay. Okay, we are inside the pod now. Now what we have to do is connect to the pSQL database again. So if you remember, in our parent cluster, we had created a database called as testDB. I'm easily able to connect to that testDB. That means our import has worked. But now the moment of truth. We had added 9 records on our parent cluster. Let's see. Voila. Now we see now we have all the 9 records that we had on our parent cluster on our target cluster. So you see what we did here is that we had we created a global repository which is accessible across all clouds. In our example, we used S3 bucket. From GKE cloud, we pushed our data onto S3 bucket. And we were able to recreate the exact same application, including data and configs, by importing just the application level snapshots or backup using a single command. So Robin automatically takes care of mapping configs from data to source cluster and data from source cluster to destination cluster. I pretty much had this today for today's demo. If you have any questions, please feel free to put it in chat. And with this, I'll hand over to Ankur. Over to you, Ankur.
Sure. Can you make me a presenter?
Yeah.
Okay, sure. Okay, I'll keep the resources screen up as we go through the questions. So Matt, have you had any interesting questions that we need to address today?
Yeah, we've gotten a few questions coming in, so we appreciate that. So I'll kind of take these in order here. So a couple of technical questions. One from Vipin was, what techniques are used to verify the backups or restores? I think maybe a question for Medora.
Can you please repeat the question? What techniques are used to?
What techniques are used to verify the backups or restores?
What we do is, for the backups, we have this, as I showed, we have used this tokens, right? And we also make sure that you have to add the exact repository. So when we use this token, we are sure that we are exporting the exact data and secure tokens, right? So we can use this to import this onto the new cluster. So in that way, we are sure that whatever backup was created is exactly available.
Okay, great, thank you. I believe you've just covered this in the later part of the demo, but does MinIO open source S3 work with CNS?
Yes, MinIO works with CNS. We have qualified it and it works just great.
Okay, great. Next question is, can we share the storage across on-prem and cloud?
Can we share the storage across on-prem and cloud? So I think what we are asking here is basically when can we have the stretched cluster? So if you have a stretched cluster, yes, we can do it. If by stretched cluster, I mean you have on-prem and the cloud together forming a stretched cluster.
Yeah, I assume that was what was behind that question. So thanks for that. Next question is, in terms of pricing, how much does CNS cost? So it's a common one we get. Maybe Ankur, you can take that one.
Sure. Yeah. So CNS is actually, we built it to be developer friendly and cloud friendly, right? So we are available on cloud marketplaces at a consumption pricing model. What that means is, you can actually pay for CNS per node hour, right? So if you're using 3 nodes for 3 hours, it is only 9 node hours you're gonna pay for. It's not an annual license. So the current pricing is 42 cents per node hour, and depending on your consumption, you would actually get the bill from the cloud marketplace. But at the same time, that is our base pricing. If you are willing to commit to a longer term engagement with Robin, there are obviously discounts. Just like in any cloud service, as you commit for longer terms, you will get discounts.
Okay, great, thank you. Couple more technical questions, probably for you, Medora. One is, how does Robin provision disks in the cloud, and does the user have to manually do this?
Okay, so while creating a cluster, Robin provides some attribute in which you can provide the cloud credentials. What do I mean by cloud credentials is, like for example, if your cluster is on AWS, if you provide access key and secret key while creating a cluster, we can use the APIs, we query the APIs, and we can spin up the apps. We have a command in Robin called as Robin drive create, which can be available to create drives. Then Robin will detect those drives and add them to their storage. We can do similarly for Azure. If you provide subscription, tenant ID, app ID, we can use those credentials, and we call cloud APIs to provision the disks. So if there are by default disks available, Robin auto detects that and adds to its database. So yes, we can provision drives.
Great. This one's more on snapshots. So how much additional space do Robin snapshots take, and can they be scheduled?
Okay, so there are 2 parts to this question. So for the first part, how much additional space? Robin by default takes around 40% of your volume size for snapshots. However, this is totally configurable parameters, and user can set according to their own needs. And second was with respect to snapshot schedules. Yes, we do support snapshot schedules. There is a Robin app level command wherein we ask for the name of the app which we have to create a snapshot schedule, and the JSON object, which actually has different parameters like the frequency or how frequent you need to take the snapshots, retention policy, and all those parameters you can set in a snapshot JSON, and we'll give it to the Robin snapshot schedule command, and we'll make sure that based on that schedule, we'll create snapshot periodically. We do support both.
I would also like to add a little bit more color for the first question, right? Because yes, we do have about, by default 40% space allocated to snapshots, but the actual snapshot itself, right? It doesn't take a lot of space on the disk, right? We allocate 40% that is configurable, and then we are assuming you're going to take, across multiple applications, multiple snapshots every 15 minutes, and that's why that allocation is there. But for a single snapshot of a single app, right, it's fairly minimal because this is redirect on write snapshots. Right? So we are not copying data every time you're taking a snapshot. We're simply creating a pointer in metadata and saying, okay, at this point in time, this was the state of the storage volume, right? So everything after that would be written to, or any changes after that would be written to new blocks on storage. But the actual snapshot will be actually, it is a minimal operation with minimal storage requirements.
Okay, yeah, thanks, Ankar. That's pretty common for these storage solutions. One final question, and we are getting up on the top of the hour here, is are there any limitations on the Robin Express edition, the free for life edition?
Sure, yeah. So, the free for life edition is, it's limited to 5 nodes per cluster, right? So you can actually have multiple clusters, and on all of those clusters, you can have 5 nodes of Robin storage free. And the storage capacity limitation is 5 terabytes per cluster. But apart from those two, there are no other restrictions. We have made all of the features that are available in Robin Enterprise are also available on Robin Express. We are not blocking any features. We are not, charging additional, or we are not basically, saying if you need, cloud backups, you have to get Robin Enterprise, right? All of that goodness of the product is available also in the free edition.
All right, thank you. I think that appears to be all the questions that have come in. So at this point, I'll just thank our speakers, Ankar and Medora, for presenting today. And thank you for taking the time to hear about Robin. And please check back for future webinar topics, which you can find on the events page on our website, so robin.io/events. As a reminder, you'll receive a link with the recording from today's presentation. And with that, we'll conclude today's session and hope you have a great rest of your day. Thank you very much.